Welcome to this explainer. Look, we all know the AI demos look like absolute magic. But today, we're moving way past the hype and diving straight into the exact engineering framework you actually need to survive in enterprise production. Because, let's be real, it's time we start treating AI like a rigorous engineering discipline rather than just a flashy magic trick. To set the stage, consider this genuinely staggering prediction from Gartner. They project that more than 40% of agentic AI projects are going to be completely canceled by the end of 2027. Why? Well, it boils down to escalating costs, unclear business value, and a massive lack of risk controls. Because, as it turns out, when you try to scale AI from a tightly controlled sandbox into a live system, things get really expensive and highly unpredictable very fast. The core issue here is that traditional software development lifecycles, our standard SDLCs, expect deterministic outcomes. If A, then B. But AI is probabilistic. It's honestly more like managing a brilliant but incredibly unpredictable intern, and that's exactly why we have to adopt the Agentic Development Lifecycle, or ADLC. This is a framework specifically built for probabilistic systems. It hardwires governance, cost predictability, and security controls right into the process to handle stuff like data drift, wild hallucinations, and completely unpredictable token burn. So here is our blueprint for actually getting out of the AI production trap. We're going to break down the 5 definitive pillars of production-grade AI engineering: the evaluation layer, observability layer, data foundation, multi-agent orchestration, and finally, governance and risk. All right, starting with pillar number 1, the evaluation layer. You can think of this as the specification layer, where we officially stop obsessing over which model is slightly better and start defining concrete numerical success metrics. We absolutely have to shift our mindset away from what I like to call vibes-driven prompting. You know the drill, treating prompts as throwaway text, running a few manual tests, and subjectively saying, "Yeah, looks good to me." That simply doesn't scale. Instead, we must pivot to strict numerical success metrics. We need to treat our prompts as versioned engineering artifacts. We're talking about establishing hard automated rubrics before writing a single line of code. To actually pull that off, you build a golden data set with your domain experts. Then you implement a really rigorous 3-layer evaluation strategy. First up, deterministic checks. This is your basic formatting or catching sensitive PII. Second, semantic checks. This is where you use an LLM as a judge to evaluate if an answer is genuinely grounded in reality. And third, behavioral checks to monitor tool calling efficiency and stop your agent from getting trapped in endless loops. Because honestly, if you can't measure it numerically, you literally cannot ship it. Moving right along to the second pillar, the observability layer. This is the transparency layer, because production AI demands absolute, unflinching transparency to debug all that non-deterministic behavior. Just imagine the 3 a.m. test. You're in a regulated industry where audit trails are mandatory. Now, what happens if your agent hallucinates a catastrophic decision in the middle of the night? Traditional system monitoring is just going to tell you, hey, the server was up. That is useless here. You have to know the exact reasoning path that led to the failure. The takeaway? You must trace everything, period. You need full visibility into the agent's chain of thought, its confidence scores, and every single API interaction or tool call it makes. Tracing decisions at this granular level is the only way you can understand exactly how a response was produced. When a user flags a bad answer, these execution traces that you instantly pinpoint. Did the agent use a bad search query? Did an API fail? Or did it just completely hallucinate? Let's jump to the third pillar, the data foundation. This is your reliability layer, the absolute bedrock ensuring your intelligent agents are grounded in actual truth. Now, it's absolutely crucial to distinguish between your serving data and your tracking data. Serving data is what fuels your user's knowledge base. Think of the documents you're pulling into a RAG pipeline. Tracking data, on the other hand, consists of your observability logs and those execution traces we just talked about. Both demand strict data engineering, but they serve completely different operational purposes. You need pristine serving data for accurate answers and robust tracking data to actually know your system is healthy. And here's a reality check about that data foundation. Agents do not forgive poor data quality the way humans do. If you or I read a document with a typo or weird phrasing, we mentally correct it. An agent, it might confidently hallucinate an entirely false narrative based on that one error. So without strong governance, like clear ownership, reliable metadata, and centralized access, bad data is essentially a one-way ticket to confident hallucinations. The AI is literally only as reliable as the data it stands on. Okay, moving up to the fourth pillar, multi-agent orchestration.
We're at the architecture layer now because going from one cute agent to an entire ecosystem causes your complexity to just skyrocket. When you start structuring agents for complex, real-world tasks, an incredibly effective approach is combining clean architecture with an event-driven setup. This is a total game changer for high-stakes AI, like in healthcare or finance. By decoupling the agent's logic from the core infrastructure, you get massive benefits. This event-driven approach guarantees modularity, real-time responsiveness, and full auditability. Every single action publishes an event, creating an immutable audit trail instantly. But how do you actually coordinate all these agents? Well, it depends on your workflow. If you need strict central control and a perfect audit trail, the orchestrator worker pattern is your best friend. Now, if you need raw speed, low latency, and parallel processing, where agents act independently, you'll want to use choreography. And for those critical workflows where safety is everything, or when an agent's confidence score drops too low, a human-in-the-loop pattern is non-negotiable.
Finally, we've reached our fifth pillar: governance and risk. This is where we stop treating AI like a one-and-done IT deployment and start managing it as an ongoing product with highly variable economics. Without proper governance, shipping AI features is basically shipping open-ended liabilities. It is shockingly common to see costs overrun by a factor of 100x just because one viral user trapped an unmonitored agent in an endless execution loop. Traditional infrastructure assumes fixed compute costs, right? But AI burns tokens, and token burn costs money. It's essentially like leaving the meter running in a taxi every single time the system makes an inference. So what do? We practice proactive financial governance by actively modeling our token economics. You've got to estimate token sizes per feature and project usage across your user cohorts. You also need to intelligently route tasks. Don't use your most expensive, heavy-duty model for a simple classification task, right? Route it to a cheaper tier. Model your worst-case scenarios. Cap your inference costs, and track your ROI just as obsessively as you track latency. As we wrap up this explainer, I want you to take a hard look at your own AI initiatives and ask yourself, are you building a resilient, production-ready product or just an incredibly expensive, fragile demo? Because surviving the unpredictability of the real world requires disciplined evaluation, absolute observability, a pristine data foundation, careful orchestration, and rigid governance. That is the only way these probabilistic systems actually succeed. Thanks so much for exploring the 5 pillars with me.